on number 2, we're not going to do all these, so let's just jump around. We'll skip 1 and do number 2 here. I mean, you guys are going to do number 1 later, but let's do number 2 together. It says, given negative 7x squared minus x to the 4th plus 2x plus 13, what is the standard form? Remember, standard form is taking your polynomial and writing it from highest exponent term down to smallest, right? Which would mean the constant at the very end. So the highest exponent term is that 4th power. So I'm going to write that first, the negative x to the 4th. That will be my first term on my standard form polynomial. And then I look for the power, since I have the power of 4, I now look for the power of 3, and there isn't any. Okay. So then I look for the power of 2. There's a power of 2 right there. So this is going to be my next term, negative 7x squared minus 7x squared. And then after that, I look for, after below 2 is 1, so I look for regular x's. That would be the 2x, so that's a positive 2x. And last but not least, the constant plus 13. So that is the answer for 2, part A, the standard form polynomial. Here it is, standard form polynomial. Now from that standard form, we could answer the rest of these vocab words. What is the degree of that standard form polynomial? The degree is 4. Excellent. Degree is the highest exponent. And as you can see, the highest exponent is 4 right there. Now the constant is the number that doesn't change. In other words, it doesn't have times a variable. It's just a number without a variable. That would be 13. So the constant's 13. And the leading coefficient, now a lot of people say negative 7. That would be incorrect because you have to look at it in order and the number that's leading out in front. Now, what number, not letter, what number? 1, negative 1, right? So there's really a negative 1 out here. So the leading coefficient is negative 1. And of course, we need to be familiar with these vocab words on a couple of the questions. Not all, just on a couple of the questions on tomorrow's test. Let's jump around here. It says, for each of the following, give the name according to the degree and number of terms. So there's only going to be 2 of these where you classify first and last name. And of course, we have the word wall to help us out, right? Now, the first name is based on degree. Okay, so degree. And we know that the degree is the highest exponent on your polynomial. So if you just happen to have like x plus 2 or x minus 7, and you don't have any exponents, that means that you have an invisible exponent of 1, and that would be linear. So if you have the exponent of 1, that's linear. If you have the exponent of 2, and that's your highest exponent, that would be quadratic. Highest exponent of 3, that would be cubic. Highest exponent 4, that would be quartic. Right? Now, if you do have an exponent of 5, 6, 7, that's not going to happen here, but maybe in Algebra 2, they ask you to classify or refer to a certain polynomial that does have a 5th degree. You would say 5th degree polynomial or 7th degree polynomial. Now, the last name is based on the number of terms, how many actual terms you have, and those terms are separated with a plus sign or a minus sign. So if you only have 1 term out there, that's a monomial. If you have 2 terms, binomial, 3 terms, trinomial, 4 or more is a polynomial. Okay. Now, of course, that's not written on the wall, but you do have those words up there, and you should be able to understand that by tomorrow. So anyway, if we look at number 3, it says 2x. We need to classify that. The first name, what's the degree? What's the highest exponent?
1.
The highest exponent right here is 1, right? So over here, what's the first name going to be? Linear, that's right. Okay, so we're going to all put linear. And now how about the last name? How many terms? There's only 1 term, so monomial, right? 1 term, monomial. Okay? So linear monomial is the correct answer for number 3 right there. How about number 4? First name is the highest exponent. What's the highest exponent? 2. So what would that be, first name?
Quadratic.
Right? 2 is quadratic. And last name, how many terms do we have there? 3? Trinomial, right? So quadratic trinomial. So don't think that there's going to be 4 of these on the test. There's only 2 of them out of 25. It's not that many, but I still need to check and see if you know your vocab, and it is up on the wall. Okay, so let's move on to the next portion of this review. The simplifying portion. This is what the major part of the test is, being able to combine like terms, being able to distribute and combine. That's what it all is about, distributing and combining. If we take a look at number 7, we don't even have parentheses, so all we have to do is combine any like terms possible, and if there are no like terms possible, at the very least, write it in order, which we call standard form, right? From highest exponent down to smallest. So what would that be in order? 5x to the third plus 7x squared minus 7x minus, I might as well do this in my head. What is a minus? Negative 7. Okay, and that would be your answer. The only thing you could do is combine what I did the squiggly underline with right there. The 3 and the negative 10. That's the only thing you could do. So when they tell you to simplify, it's do anything possible. And the only thing possible on this problem is to combine the negative 10 with the 3. And that's how we get that constant of negative 7. If we look at anything that has a parenthesis, like number 8, I have a parenthesis right here. Okay? Now, is there any number out here to distribute? No. If I did have a 2 right here, now I don't, all right? Now, don't write this down. But if I had a 2, I'd have to distribute 2 into each and every term. But I don't, okay? Sometimes we have numbers out there. Sometimes we have letters. Sometimes we have signs to distribute. Now, what do I mean by signs? You might have a minus sign or a plus sign. So as you can see right here, we do have a minus sign that we need to distribute. So it's kind of like saying a negative times a positive, well, that's going to be a negative, so that's really a minus 4x squared. A negative times a negative, that's a positive, so that's really a plus 9x. A negative times a positive, that's a negative, so that's really a minus 5. So whenever you have anything outside in front of the parenthesis, you have to distribute it in. Make sense? Okay, so we did say that there was nothing to distribute in the first one. There's nothing right here, so I could just rewrite it. Let me rewrite it. We have a 2x squared, we have a minus 6x, we have a plus 11, and I still need to combine like terms. So again, standard form, you want your highest exponent term first. So let's start combining the x squares with the x squares. So if I combine 2x squared with a minus 4x squared, what do I get? Negative 2x squared. And if I combine the minus 6 with the plus 9, what do I get? Positive 3x, all right? And last but not least, plus 11 minus 5. Positive 6. And we're done. Easy, right? So always check and see if you need to distribute anything, right? Number 9. Is there anything to distribute out here in the front? No. We do have a plus sign, but if we distribute a plus sign, it doesn't change anything, right? If I wanted to, positive times a positive, it's still going to be positive. Positive times a negative, it's still going to be negative. So right here, the plus sign, it doesn't change anything. So I could just combine like terms. In other words, I could ignore the parentheses because the plus sign doesn't change anything, okay? But it's still important to try to distribute something. The plus sign, if you distribute it, it doesn't change anything. So let's just start combining like terms. We have a 4x here and a 19x here. What do I get when I combine them? 23x. And then we have the minus 1 and minus 8. Negative 9. Yeah? Good question. You're saying, isn't it supposed to be x squared? Now let's think about what x squared really means. X squared means x times x, right? So right here, were we multiplying? No, we weren't, right? So that's a very good question because it brings up the fact that you only change exponents when you're multiplying. You do not change exponents when you're adding and subtracting. And that's clearly what we're doing here. You owe $1, you owe $8, you're going to owe $9. We weren't multiplying negative 1 times negative 8 get positive 8, we didn't multiply. We're combining like terms, right? So good point. When you do have an x and you're combining it with another x, you're not multiplying. That's why we got 23x. But if we were multiplying, like if we were distributing and you had x times x, then yeah, for sure, x squared. Like let's look at one where we are multiplying. Like down here, number 14. Like I said, always check and see if you have anything on the outside of the parenthesis that you need to distribute. Number 14, we have many things to distribute. We have a 3m. So 3m times m squared. What do I get? 3m times m squared. Okay, 3m to the third. And then 3m times negative 4. Negative 12 with an m. Okay, and then we need to distribute this minus 2. Minus 2 times positive 6m to the third. And negative 2 times negative 2m, positive 4m. And then negative 2 times positive 1, negative 2. So we have this ginormous polynomial that we need to combine like terms with. So we have the 3m to the third with the minus 12m to the third. And what do I get? In other words, you have 3, you owe 12. Negative 9m cubed. And Jezreel, notice that right here, the exponents do not change. We're not multiplying. Up here, when we originally went 3m times m squared, yeah, it changed because we're multiplying. But down here, you're just combining this guy with that guy. It's like I have $3, I owe $12. I'm still going to owe $9. But it's not dollars, it's m to the thirds that we're actually combining. So let's move on to the m's now. We have a negative 12m and a positive 4m. What's up there? Negative 8m. And last but not least, we have this constant of negative 2. Let's bring it down. And that's it. That's your answer. Okay? So always check and see if you have something to distribute. Like number 12, what do we need to distribute on number 12? The minus sign, right? So you have to change all those signs. Let's see a different one. How about number 11? What do I need to distribute? Nothing, right? Because if I did distribute the plus sign, it wouldn't change anything. Now, again, guys, I don't want you to mess up on these. When there's a plus sign, you are not multiplying. Okay, you are not multiplying. You're not going to say 3x squared times x squared. Don't start distributing. This is a plus sign, so you're just going to be combining like terms. Noise. Number 10. Do I need to go 12x times 8x? Do I need to do that? No, I'm not distributing, right? Okay. If I do want to distribute something, what would it have to be? What do I need to distribute? The negative sign. Yeah, that's going to change it to a negative 8x. That's going to change that to a positive 10. And there's nothing to distribute out here, so I'm just going to rewrite it without the parentheses. 12x minus 2. And then I'm going to combine like terms. Oh, the x's with the x's. I have 12, I owe 8. I'm going to have 4 of those x's left over. And then minus 2 plus 10, that's a positive 8. And that's our answer for number 10. So on this whole first part, from number 7 all the way to 13, that is just adding and subtracting. Okay, just adding and subtracting. Now, there's not going to be that many adding and subtracting on the test. The majority is what's on the other side, page 2, where you do have multiplication by doing distributive property, and then after distributing, you have to combine like terms. So that's why we're not doing that many questions on adding and subtracting, because on these questions, you're going to have to combine like terms anyway. Okay? So the majority of the test comes from here, where you have to distribute one term at a time, and then combine like terms. So 15 or 16, pick one. 16, all right. Right here we have a monomial to distribute to the trinomial. So negative 2xy times 3x squared. Let's do one piece at a time. What is negative 2 times positive 3?
Negative 6.
Negative 6. How about x times x squared? X to the third. And then the y times, is there any other y in that first term? No, so I just bring down the y, and that is our first part of our answer. And then I go negative 2xy times negative 5xy, again, a piece at a time. Positive 10 x squared y squared. Perfect. You do the numbers first. Negative 2 times negative 5 is positive 10. Then you do x times x is x squared, and then y times y is y squared. Last one. Negative 20 xy. Perfect. Done. So those are pretty straightforward. Now, the ones that get a little more fun are these guys down here, because we don't have, like up here we have one term to distribute. On number 16, we distributed that monomial into the trinomial. Down here, we have a binomial to distribute into a binomial. So what we're going to do is simply one piece at a time. I want to start by distributing this 3x. 3x times 3x is what? 9x squared. And then 3x times negative 7y. What's 3 times negative 7?
49y squared.
Negative 21. And then, yeah.
I thought you were doing the 7.
And I'm going 3x times negative 7y. So 3 times negative 7 is negative 21. And then how about this x times this y? What do I get? xy, right? It stays the same, xy. So now that I've distributed the 3x, now I'm going to distribute this positive 7y. So positive 7y times positive 3x, positive 21, and then y times x is yx, but I'm going to write it in alphabetical order, xy. And then positive 7 times negative 7, and of course with the y times y, we get a minus 49y squared. And of course, the middle terms, what happens to them? Cancel out. So we have 9x squared minus 49y squared, and that's your answer. Now we should have seen that coming, that the middle terms are going to cancel out, because we have the same exact binomial, but one's a plus, one's a minus. Okay? So that's about it, guys. I mean, that's as hard as it gets. Don't forget on these guys, you have to write it twice, right? You have this binomial squared. That means that binomial times itself. So that's the first step, writing it twice. And then after that, we're going to distribute 4x times 4x. That's 16x squared. 4x times negative 5. That's negative 20x. Negative 5 times positive 4x. That's negative 20x. And negative 5 times negative 5, positive 25. Now, do the middle terms cancel out right here? No. The only times the middle terms cancel out is when you have the same binomial times the same binomial, 1 plus, 1 minus in the middle. So that's not the case here. So let's combine the middle terms. It's kind of like doubling that negative 20. You're going to end up with negative 40. So you really have as a final answer 16x squared minus 40x plus 25. And
What about 30?
30. Oh yeah, that's like the only equation. We probably should have practiced more equations. I think there's 2 equations on the test. Remember, when you're solving an equation, treat the equal sign like a wall that divides your equation. Okay? Like there's a wall right here. So let's simplify the left side, simplify the right side, and then worry about getting x by itself, or in this case, b by itself. So on the left side, let's distribute 2 times 3b. What do I get?
6b.
Okay, and then 2 times 2? Plus 4. And that's all I could do on the left side. Okay, on the right side, let's distribute 3 times b, 3b, plus 9, minus 7. And what is 3b plus 9 minus 7? What is 9 minus 7? Positive 2. So let me do this. Let me erase the wall now. Let me put an equal sign right here to create a new equation. I want to do it in black. So I have 6b plus 4 on the left side. I have my equal sign. And then I combine this with this, and I end up with 2, right? So I have 3b plus 2. So I need to solve this thing. I need to get b by itself on one side of the equal sign. So where's the b at? Is it on the left side of the equal sign, right side, or both sides? Both sides. You don't want it on both sides, so we need to get rid of one of them. Which one do we get rid of? 3b is a good idea. How do we get rid of something? You do the opposite. Subtract it. 3b take away 3b is 0. It's gone. 6b take away 3b, because what you do to one side, you have to do to the other. Positive 3b plus 4 equals 2. And then minus 4, minus 4. What do we end up with? Let me rewrite it over here on the side. 3b equals negative 2. Now, 3b really means 3 times b. So to get rid of the multiplication of 3, I need to divide by 3 on what I do to one side, I do to the other side. And that's great that we get a fraction. B equals negative 2/3. Why do I say it's great? Because on the test itself, I remember seeing the answers being fractions. Okay, but this could be, it could be the question on the test tomorrow. At least it's very similar to it, I'll tell you that. We are going to end up with a fraction on the equation. Anyway, I'm done. You guys need to finish this up. The answers are on the back wall. Please check your answers as you go. And make sure you finish all homework from Chapter 8. And we're also going to turn in notebooks tomorrow. And tomorrow's the last day of school. We'll be able to enjoy our spring break.